work with Ohm's Law, and we're going to use Ohm's Law to fill in a missing value. Ohm's Law looks a lot more complicated than it is because they use some fancy letters, but I want to explain what the letters are, and we'll substitute the letters with their real values. So Ohm's Law, you're going to see this symbol a lot. And I write this up here because it's easy for me to remember. And once you associate these letters with what their real values are, it becomes easy to work with this and remember it. It's something that you'll never forget. Okay. First, E. Well, E is voltage, but the E stands for electromotive force. Okay. I'll say that again. Electromotive force. That's pressure. Okay. Or how hard electrons are being pushed. I stands for amps. I had a student ask me, Spreader, what's the I stand for? Because amps starts with an N. You're right, excellent spell. Amps does start with an N. I actually stands for the French word for intensity, which also starts with an I. So I stands for current. We measure current in amps, and that's how many electrons are flowing in a circuit at any given time. Then R stands for resistance, and we measure resistance in ohms. So I know that's a lot in this little circle right here, but I'll say it again. E stands for volts. Voltage is pressure, and the E itself stands for electromotive force. You'll hear voltage referred to as electromotive force. I stands for amps or current, and R stands for resistance. Now, you're looking at the circle and maybe you don't know how to use it, but it's really, really simple, okay? You're probably familiar with these math problems since maybe 5th or 6th grade, where 3 plus x equals 5, okay? Well, what's x? It's 2. Ohm's Law is no different. It's the same as putting E, I, and R in the right spot and then calculating the missing value. So let's look at what this really is, E over IR, okay? Remember, E is voltage or electromotive force, and in the automotive world, E is not a variable that changes too often. We're locked in at 12 volts. Now, some people may argue with me that it's not 12 volts, it's 12.6, and then charging voltage is 13 to 14. You're right. But so we don't have to take our shoes off the count, I like to just substitute the 12 in here to get the idea. All right? So voltage or electromotive force, okay? We take voltage, and voltage equals current times resistance. So if you take current and you multiply it by your resistance, it will give you voltage or electromotive force. Very rarely are we looking for voltage in a circuit because it's a given value. More often, we're looking for what's the current in the circuit or what's the resistance of the load. So we'll work with this circuit right here where we know the voltage and we know the resistance, and we'll calculate the current for this circuit so we have an idea on what it needs to be fused for. Okay? So we take 12 volts. That's our E. Okay? So we got 12 volts, and we need to divide 12 volts by our resistance, 2. 12 volts divided by 2 ohms equals 6 amps. So this circuit right here is going to draw 6 amps. We don't always have to plug the math in to get an idea of what's going on. And I want to show you this relationship so you start to understand that as resistance decreases, current increases. So in this circuit right here, I'm going to change my resistance value. I'm going to decrease resistance by 1 ohm. So my resistance in this circuit went from 2 ohms to 1 ohm. So now when I plug this into Ohm's Law, 12 volts divided by 1 ohm of resistance equals 12 amps of current. So you can see that the current went up in our circuit significantly as the resistance was lower. All right. The other part of this is as voltage or as pressure increases, so does current. So if I change my battery voltage from 12 volts to 24, okay, and that's not easy to do, you're going to need a second battery, and you're going to have to wire them in series. But if I change my battery voltage to 24 volts, and I keep my resistance at 2 ohms, the same is true. 24 volts divided by 2 ohms of resistance equals 12 amps of current. So Ohm's law is just a way to calculate the unknown value out of current, voltage, and resistance if you know any two. Right? So if you're asked to solve Ohm's law equations or find a missing value in an equation, understand that you only need 2 to find the missing value. If you're given an assignment and you have to apply Ohm's law to a wiring diagram and you are not given any values, you can add any values that you want as long as they make sense, and when you put them in Ohm's law, they equal out. Okay?